All right, Chem 11, we are back. What we're going to do today is another one of our problem-solving sessions, and we're going to be dealing with the pH and pOH worksheet that was left for you on the D2L class page. All right, so to do this, what are we going to need? Well, we are going to need obviously the handout, which I have right here, printed off, and I'm going to need the Calculator-O-Matic 3001. Again, when I'm doing the pH stuff, I need this logarithm button, which is right here on this calculator. The original Calculator-O-Matic 3000 doesn't have that. So I'm going to be using that log button today. So I got to use this guy. Still has solar power though. So when a comet strikes the Earth and knocks down the power grid, this guy's still doing some chemistry work. Anyway, what I'll do today, I obviously can't do all of the problems, but what I'm going to do is I'm going to do all the odd numbered ones. So that's what we'll do today. So 1, 3, 7, 5, 9, or 1, 3, 5, 7, 9. Anyway, so we'll do the odd numbered ones. There was 13 of them on the sheet, so you get a little bit more bang for your buck than me doing the even numbered ones. So question number 1. Now I'm going to answer these the exact same way that I would expect you to answer them, showing the exact same work and stuff like that. And I'm going to think it out. I'm going to talk the same way, that I would be thinking in my head. So number 1, what is the pH of a substance with a hydronium ion concentration of 5 times 10 to the negative 1 moles per liter? Okay, so we're looking for pH. And it says that it has a hydronium ion concentration. Now remember, hydronium is the thing that links up with pH. And the concentration they give us is 5.0 times 10 to the negative 1. Now these problems tend to use a lot of scientific notation. You have to get comfortable with that, right? Or if you want, you can put this into a decimal, times 10 to the negative 1. Really what that is, it would be 0.5, right? So 5 times 10 to the negative 1, well, we're taking that decimal, right? That was here at 5.0. And we're moving it back 1 spot. If putting that in makes it more comfortable for you, that's no problem. Just be mindful that we're using, -7, -9. That's going to be a lot of decimal places and a lot of writing rather than this condensed form here. All right? So I'm going to stick with the scientific notation. I have no problems using that. I know they do scientific notation in grade 9 math. That's a few years back for you guys, but you should be handy with it. First thing I'm going to show is my formula. So they've given me the hydronium ion concentration, and that is equal to negative log 10, and this number is going in there, 5.0 times 10 to the negative 1 moles per liter. When I enter that into the calculator, my pH is equal to 0.3. All right, so that's my final $1 million answer for number 1. So that's a very strong acid for sure. All right, 0.3, I mean, 0 is as strong as it gets, and this thing's just above that. So we'll do number 3, and we'll do that one in the orange. Number 3. What is the hydroxide ion concentration for calcium hydroxide solution with a pOH of 3? So CaOH2 is calcium hydroxide, and the pOH is equal to 3. All right? So I know I received a message or two asking about this one because a lot of students seem comfortable when I give you the molarity or the concentration for hydronium or hydroxide. But if I give you the pH value or the pOH value, that seemed to trip some people up. So here's how that works, all right? If I go with my regular formula, which in this case is going to be pOH, not pH, because I'm given the value for hydroxide, so I got to use OH. There's my formula. Now, if you're thinking about it, what you were given, right, was this. So you pop in the 3 there, negative log 10 OH negative concentration. Now, This is what kind of trips people up. There's no way to just, it's not like this is multiplied by 100%, so I divide by 100% over here. This logarithm to the base of 10 is the part that's tricky, right? Basically what happens is the concentration that we're trying to find, right? We're trying to find hydroxide, becomes this. So our concentration becomes 10, because our base was 10, and this becomes a negative exponent. So the pH or the pOH becomes a negative exponent. And that value will be in moles per liter. All right? And so when I put that into the calculator, I will get 1 times 10 to the negative 3 moles per liter. That's my concentration, which basically looks like the same thing. Or if I'll put or here. If I were to put this as a decimal, it would be 0.001 moles per liter. All right? These two values, I'll underline them in pink. They're exactly the same. So this value and this value are the same thing. Either one is acceptable on a quiz or a test, right? So this and this. All right? Same thing, moles per liter. And all I did was I took this value for the pOH, and if this was a pH question and I had to find hydronium, I would do the same thing. And I make it a negative exponent to the base of 10. All right? So 10 to the negative 3. Right? Think about it that way. So whatever that pH or pOH value is, it becomes a negative exponent here. All right? And this is your scientific notation answer. This is your expanded or regular version answer. All right? Either one of those is totally fine with me. Anyway, pause the video if you got to get those down. That's 1 and 3. We've still got a few more to go here. And I'll set them up. All right. Next one is number 5. We'll do it in red here. And number 5 says, what is the pH of barium hydroxide? So I got to get this formula down. Solution with a concentration of, so the barium hydroxide with a concentration of 3.45 times 10 to the negative 3 moles per liter. All right. So there's what I am asked. Now, it's very important, right, to notice in the question, what is the concentration of, right? So I'll put this up here. This is a key thing. If I'm given a concentration, what is it the concentration of? That's what I got to figure out. Now, in this case, the concentration that I was given is not for hydronium. I can't do the hydronium thing right away. It's not that H3O thing. The concentration is of this. All right, this concentration is for this. So I can't do the pH formula for that reason, right? And here's, again, explaining that. I can't do pH right away because this concentration is not for hydronium. The pH formula has that hydronium in it. This concentration is for this base, and this base is going to release these hydroxides. So I have to use pOH first. But before I can even do that, right, I'm actually glad we're doing this question because it's got all the steps that we will ever have to face all in one. So before we even do that, we've got to convert this from a concentration of barium hydroxide to just a concentration of hydroxides. So let's do that, all right? So I'm going to take this number, right? Nope. So what I'm doing is I'm basically doing this. I'll write it out really quickly. This is what I was given, and this is what I want. If I get this hydroxide concentration, that is going to be what I can pop into pOH and then relate pOH to pH. All right? So what I'm going to do is I'm going to take the concentration of this, and I'm going to take the moles. It's all per 1 liter, so I'm going to take that moles right there. I'm going to multiply it by, there's 2 OHs, right? 2 hydroxides for every one of these base molecules. This is a base. So what I'm going to do is I'm going to multiply it by 2 moles of OH negatives for every mole of BaOH2. All right? And what ends up happening is there's a cancellation that goes out. This is moles of BaOH2. This is moles of BaOH2. And I'll be left with moles of hydroxide. So that ends up being 6.90 times 10 to the negative 3 moles of the hydroxide this time. And so now my concentration, right? So therefore, I think I'm going to ditch this red marker after this question. Therefore, if I have this many moles in the 1 liter of barium hydroxide, I have this many moles in the 1 liter of the OHs. Right? Let me say that again. This is how many moles in 1 liter I have of this. And every one of these has 2 OHs. So if I had 10 of these, I have 20 OHs. So I took the moles of the barium hydroxide and I multiplied it by 2 moles of hydroxide for every mole of barium hydroxide. These canceled out and I was left with moles of OH negatives. And because it was taken out of the 1 liter, I know my concentration is 6.9 times 10 to the negative 3 moles per liter. Now I have OH. So now I can do the second step. I take this value and I put it into my pOH formula. Which is this. And then I work it out. I pop in the value for the concentration that I just figured out. Oh, don't forget my scientific notation. And my pOH, come on red marker, I just need you for a couple more seconds. My pOH is equal to 2.16. The question asked for pH. So now I take this value, and I'll put it here. I normally put it under here, but I know that if I have the pOH, I can figure out the pH. Because pH plus pOH is equal to 14. So my pH plus 2.16 is equal to 14. Which means my pH is equal to 14. If this is plus 2.16, over on the other side it'll be minus 2.16. And so my pH is equal to, and that is going to be 11.84. And that makes sense. It should be higher than 7, right? So if I had stopped here, right, then I'm saying, oh, this is a base. It's got hydroxide. I know that that's a base. Its pH is 2. Well, that doesn't make sense, right? A base has to be above 7. So remember, you calculate the pOH, and then you do this little step over here. I'll draw an arrow just to say that this is next. And so I figured out it's 11.84. That makes more sense because it was a base. All right, that's number 5. Number 5 is probably as complex as these problems will get. I don't see it getting any harder than this. So if you understand number 5, or you understand it as I'm explaining it to you now, then you're good to go with the rest of this. All right? Pause the video. I'm going to get number 7 and 8, or sorry, number 7 and 9 set up. red marker, you are out of here. All right. Blue is working really good. We'll give blue a try. So number 7. A solution has a pOH that is 10.7. What is the pH? Oh, this one's beautiful. This is an easy one. I know that pH plus pOH have to equal 14. All right, we just kind of did this step in the last problem. So what I'm going to do is I'm going to say, if this is plus pOH, on the other side with the 14, it would be minus pOH. And so pH is equal to 14 minus the 10.7. And that means that the pH is equal to 3.3. And 3.3 is my final $1 million answer. All right. That was a nice, easy one. Number 9. Let's check out number 9. What is the pOH of a sample of calcium hydroxide that has a concentration of 3.4 times 10 to the negative 3 moles per liter? So I got to find pOH calcium hydroxide. So number 9 I'll do in green, and I'm looking for the pOH of a calcium hydroxide solution that has a concentration. So it's this that has a concentration. They didn't give me concentration of hydroxide. They told me the concentration is of calcium hydroxide. Remember I said Remember I said concentration. You got to be careful of the wording of what they give you. They didn't give me hydroxide, so I can't pump it into here right away. All right? So the concentration of this is 3.4 times 10 to the negative 3 moles per liter. All right. So to find pOH, I know I'm going to need this at some point. I'll show you. I'll do it. All right. To find pOH, it's equal to negative log 10 of the hydroxide ion concentration. I wasn't given this. I was given this. So I'm going to have to do that step like we had in number 5. I know that every calcium hydroxide has 2 hydroxides in it. So I'm going to take the molar amount of this and do that extra step. So 3.4 times 10 to the negative 3 moles of CaOH2, and I'm going to multiply it by 2 moles of hydroxide for every 1 mole of CaOH2. And then what happens is you can see the moles of calcium hydroxide on top and on bottom will cancel when I multiply. And I'll be left with moles of hydroxide, which is what I need to find pOH. So when I multiply that, I end up with 6.8 times 10 to the negative 3 moles of hydroxide ions. And that is what I'll use down here. Now, because that was the moles per 1 liter, this is also the moles per 1 liter. So I'm just going to adjust that right here. Again, because this was the moles of this in per 1 liter, this is the moles per the same liter. So per 1 liter. So that is my hydroxide ion concentration. That's what I'm putting right here. I'm putting this number right here. So when I do that, it'll be negative log 10, and this value is right here. And that is equal to 2.17. So that is my pOH. And that is your correct $1 million answer. All right. So, again, be careful of what their wording is for the concentration. All right. This one said the concentration of calcium hydroxide, not just hydroxide. So because of that, I had to do this little middle step here and get this value, which goes in for the hydroxides. All right. Number 11 is coming up. Pause the video now if you need to get those down or take a look at them for a bit. I'm going to do number 11. Number 11. Do number 11 in pink here. All right, number 11 is asking, what is the pH of magnesium hydroxide that has a hydroxide ion concentration? So again, the concentration given is hydroxide, not the magnesium hydroxide. 4.8 times 10 to the negative 2 moles per liter. All right, so again, this is the base, but they've already given me the OH. All right, I'm looking for pH. Now, pH uses hydronium, right? That hydronium is this thing, right? I wasn't given that. I was given these, right? pH uses this. I was given these. So I can't find pH right away, but I can find pOH. So that's what I'll do. So pH is equal to negative log 10 of the hydroxides. And pOH is equal to negative log 10. I sub in this value right here, 4.8 times 10 to the negative 2 moles per liter. And I find out that my pOH is equal to 1.32. All right. It didn't ask me for pOH though. It asked me for pH. So I have to do this. pH plus pOH is equal to 14. And that means pH is equal to 14 plus pOH, which means when it comes over, it's going to be minus pOH. And that means pH is going to be equal to 14 minus 1.32. And that's going to give us 12.68. And that is my pH. And that makes sense because I see that this is a base and this is a basic pH. There's my $1 million final answer. All right, so that was my pH right here. All right, if I had to just stop here, I'd be saying, oh yeah, this base, it's got a pH of 1. And you're thinking, well, that's way below 7. That can't be, right? Remember, think out your answers ahead of time. Think where they need to be. All right, that's number 11 done. So let's move on to the last question, number 13. Mowing these down really quick today. Lucky number 13. 13. All right, let's get that sheet. Number 13 says, what is the hydroxide ion concentration of a solution of lye? So I'm looking for this. And it's lye. That has a pH of 12.5. All right. Let's see what I'm given here. I got to find this. I know to find that I don't use pH. pH doesn't link to OH negative. Remember, pH links with hydronium, the H3O thing. So I've got to turn this into pOH. That's easy enough because I know pH is equal, or sorry, pH plus pOH is equal to 14. That means that pOH is equal to 14. This is a positive pH. Over here to be a negative pH, minus pH. So pOH is equal to 14 minus 12.5 and my pOH will be 1.5. All right, now that's the pOH. It asks for concentration. So I take this over to here, and I know that pOH is equal to negative log 10 of the hydroxide ion concentration. So there's what I'm looking for right there. And I'm given this. I'm given that pOH value. And again, this is one of those ones where it doesn't cancel out, like there's no easy way to show it. So basically you have to understand that if you're given the pOH or the pH, we do this. We take the 10, and that's your base, and this becomes a negative exponent. So you put that into your calculator, and it's going to be in moles per liter. It's a concentration. And when you do that, you will get one of two answers. I will put both of them here, and you can decide which way you like it. So 3.16 times 10 to the negative 2 moles per liter, or if we want to do the decimal, 0.0316 moles per liter. Either of these is absolutely fine, right? It says or, so this or that. And just remember what we did. This little 10 becomes your base, and this becomes your negative exponent. All right? This is our final answer, both in scientific notation and in expanded version. I'm going to do number 12 as a bonus, because we went through those pretty quick. Pause the video right now if you got to get that down. I'm going to do number 12. All right. Number 12. Number 12 asks, what is the pH of 5.5 molar phosphoric acid? Phosphoric acid is H3PO4. Man, I hope formulas are easy for you guys. Orange looks like it's a little fading. This might be its last question. All right, so what am I going to do? Well, I know that this is the concentration of this. Again, what do you have the concentration of? pH, right? If we look at it, pH is equal to negative log 10 of the hydronium or hydrogen ion concentration. I don't have this, right? They didn't give me the 5.5 molar is for this. It's not for the hydronium. So what I got to do is I got to convert this into this, right? We got to do that extra step. And I know that 5.5 molar, right? That means 5.5 moles per liter, right? That big M means moles per liter. It's molarity. So what I'm going to do, oh, sorry, I copied that down incorrectly. It's 0.55. Yikes, good catch. It would be embarrassing to go through all that. Have someone message me that I didn't know what I was doing. 0.55. All right, so there's my concentration. It's the same as this. All right, so I'm going to start with this. This is my concentration of that, so 0.55 moles. Now, what this means is 0.55 molar. I have 0.55 moles of this H3PO4 in every liter. So I'm going to keep the liters off to the side. I'm just going to do how many moles are in that liter. I'm just going to deal with that. So this is moles of H3PO4. Now to make hydronium, a little side note here, to make H3O, right, plus what I have to do is take a hydrogen and add it to a water. So how many hydrogens does that have? It has 3, right? So I'm going to multiply it by 3 moles of H3O plus. Now the reason I'm doing that again, there's 3 H's that are going to separate when this acid, phosphoric acid, which is very strong, When it drops into the water, the phosphate's going to go one way, and the 3 hydrogens are going to do this. 3 hydrogens are going to meet up with 3 H2Os and give us 3 of those. So what I did was I took my moles of H's and I basically said, well, if the H's are just going to form hydroniums, then I'll just do the hydroniums right away. And it's totally acceptable. And so there's 3 moles of hydroniums made for every mole of H3PO4. And what that will equal is 0. Oops. I have to fix something, didn't I? I messed something up here. You know what? I messed up the decimal even worse. It's a quick fix though. I messed this one up. It's 0.055. Sir needs reading glasses, apparently. It's that. All right, I do apologize for that. That's my 3rd time doing that. Anyway, so I multiply that, and what I end up with is 0.165 moles of H3O plus. And because this was per 1 liter, right, then this is also per 1 liter. So the hydronium, the H3O plus concentration, is 0.165 moles per liter. All right, I'll erase this. This is the value that goes in here. See, I do a bonus question and it totally derails on me. Stupid, sir. And so our pH is going to be, when I run that through, 0.78. Phosphoric acid's pretty strong acid, so I'm not surprised. It's very, very acidic, very low on that pH scale. And there's our $1 million final answer. So sorry about that. Again, I had messed up with this original value. I'll rewrite it at the top here so that we can. So we were looking for pH, and the value given was 0.055 molar. I misread that, and that's the same as saying 0.055 moles per liter, and that's what I started with here. I took that 0.055 moles, and I started with it right here. All right? And of course, these things canceled out. So I do apologize for the rough start to that question, but the proper answer is here on the board now. So pause the video and get that down. I am done. We've covered a lot of different types of questions today. Hopefully everything was crystal clear except for the bonus 1 even question that I did. But we fixed it, we caught ourselves, and that's it. Hope it was crystal clear. Any questions or comments or concerns, fill them into the comment section below this video, or reach out to me through EDSB if you're one of my students. Anyway, hope this helps. Talk to you soon. Bye-bye.